The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to take a look at section 10.4. It says we will also be covering section 10.4 tomorrow. That's a lie. Tomorrow is Veterans Day. We'll be covering 10.4. I should put down here Friday. All right. There we go. Okay. Except that it's capitalized. All right. Anyway, sorry about that. Off to a great start here. So I'm going to switch screens now to, what I was going to say was, so your homework, I guess we're going to spend 2 days on 10.4. There's actually kind of two parts to it, but if you over Veterans Day want to work on it and get it finished, that's great. If you want to look in the Math 93 videos on YouTube, it's broken up into two sections, 2 days, 10.4 part 1 and 10.4 part 2. So I'm going to probably do the first part today. Anyway, enough of that. Let me switch over to a different screen. Yeah, it's loading here. Okay, oops, that. And okay, so can you now see the graphing screen? Yes, great. All right, so what we're going to be looking at today is graphing second degree or quadratic functions or quadratic equations. So the most basic one would be f of x equals x squared or y equals x squared. What I want to do for starters is just go through and calculate the y values and graph this function. Now, notice my x values go from -3 to +3. I think I may have said this before. Whenever I'm graphing some function that I supposedly don't know anything about, I tend to take the x values from -3 to 3, see what I get, and then go from there. So that's what I'm going to do. All right, so f of -3 is -3 squared, which is 9. I'm going to switch over to black instead of blue. Okay. F of -2 is -2 the quantity squared, which is 4. F of -1 is -1 the quantity squared, which is 1. F of 0 is 0 the quantity squared, which is 0. F of 1 is 1 the quantity squared, which is 1. F of 2 is 2 the quantity squared, which is 4. And f of 3 is 3 the quantity squared, which is 9. Okay. Notice there's two different x values have the same y values. So when x is -3 and +3, the y values are both 9. When x is -2 and +2, the y values are both 4, etc. This is still a function. You can have more than one input going to the same output. You just can't have one input going to more than one output. So this is a function. And let's graph those points. -3, 9 is right there. -2, 4. -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. Now, obviously, if this is a linear function, I've messed up big time. It's not linear. And let's see here. Oops. Let's try that, see if I can do that a little bit better. There we go. Not much, but a little bit better. All right. What we have here is called a parabola. Okay, P-A-R-A-B-O-L-A, a parabola. And let's see if I can write that a little more legibly. Parabola. And it has some features that I want to talk about. This parabola, we say, opens upwards. When it opens upwards, the lowest point in the parabola is called the vertex. In this case, the vertex is at the origin at 0, 0. All right. Also, this parabola has symmetry. If we were to take the y-axis and we were to fold a piece of paper along the y-axis, this parabola, we see that it's symmetrical. This distance here is the same as that distance. This distance is the same as that distance, et cetera, et cetera. So this thing right here is called the axis of symmetry. And it is always an equation describing a vertical line. It's always in the form of x equals whatever x value that is, and that would be x equals 0, because every point on that dotted line would have a x value of 0. So it has an axis of symmetry at x equals 0 and a vertex at 0, 0. Also notice the axis of symmetry goes right through the vertex. This is always going to be true. Okay, before I go on, any questions so far? All right. So on this next screen, I have the parabola that I graphed on the previous screen. But now we're going to explore a little bit. We're going to change the coefficient. Right here, the coefficient is an implied 1. All right. But we're going to change it to a 2 and then to a 1/3. So we're looking at equations in the form of y equals ax squared. In the first example, the one I did on the previous screen, and this black one here, a is 1. Let's take a look at the red one. Okay. Now I've already gone ahead and notice I'm using the same x values, but what happens when I increase a and make it greater than 1? The graph climbs faster, steeper, if you compare this one with this one. What if a is less than 1, between 0 and 1? The graph climbs not as steep, so it opens wider. Okay. Any questions about those examples? All right. Back to our y, or f of x equals x squared. Now we're taking a and making it a negative value, -1. So if I compare this with this, all my y values here are negative. So instead of opening upwards, the graph opens downwards. Okay. So what did we figure out so far? Well, if a is greater than 0, the parabola opens up. If a is less than 0, the parabola opens downwards. Okay. Now, what if we take f of x equals x squared, and now we're going to use this form where we're going to add a constant out at the end, a separate term. Okay. So f of x equals x squared, we have this black graph. G of x equals x squared plus 2, we have this red graph. Notice I'm using the same x values that I used here, but now because of the plus 2, the y values are 2 more than the y values there. What does that do to the graph? It moves it up the y-axis 2 units. So when x is a positive number, it moves the graph upwards. Look over here. When x is a negative number, it moves the graph downwards. Okay. Any questions there? All right. Now, we've gone inside the x squared. Here again is f of x equals x squared. We're going to put a -2 inside here, but now instead of using the same x values, I'm going to use the same y values that I used before. But because I take x and subtract 2 before I square it, if my x values are 2 more than they are over here, putting an x value that's 2 more and then subtracting 2, it gets back to these same x values, so I get the same y values. What does all that mean? Well, look at what this graph looks like compared to that one. It has shifted to the right 2 units, but it was an x minus 2. Let's go back for a bit here. Back here, when we had a +2, it moved it upwards, and a -2, it moved it downwards. So a positive up, a negative down. That seems reasonable. But here, a negative moves it in a positive direction, and a positive moves it in a negative direction. So what happens outside, you could say is obvious, but what's inside is the inverse of what you might expect. And we'll talk more about that in a little bit. All right, so here's one that's got everything going on, okay? And we looked at A. If A was positive, the parabola opened upwards. If A was negative, the parabola opened downwards, okay? If A was greater than 1, the parabola opened upwards but got steeper. If A was between 0 and 1, the parabola opened up but opened wider, okay? If there was a K value out at the end, a constant, the parabola moved upwards. If A was positive, excuse me, if K was positive, upwards. If K was negative, downwards. Inside, H affected the movement this way and this way. If we had X -3, it moved it in a +3 direction. X +4 moved it 4 units in a negative direction, okay? So what's inside, it does the inverse, and what's outside, it does the obvious. So what I want to do is go back again to all of these things and talk about the vertex, okay? Here, the vertex is still at the origin. Here, the vertex is still at the origin. Here, the vertex is still at the origin. My graph's off there a little bit, but so just by changing A, that coefficient in front, it didn't affect the location of the vertex. So anything in this form, your vertex is always going to be at the origin. But now, the mouse there. Here, same thing, doesn't affect it. But look what happens here. The vertex here is at 0, 0, but here it's at 0, 2. And here it's at 0, -3. So that K value appears to be the Y value of the vertex. See what I'm talking about? And here, the H, well, let's see, here the vertex is 0, 0. Here it's at what? 2, 0. And here it's at -1, 0. So that H value also affects the vertex. It affects the X value of the vertex. And it's the inverse of what you see there. Okay, so what does all that lead us to? Well, here's the deal, okay? And let's go back, let's see here. And just look at Y equals A times X minus H squared plus K. The vertex is at HK. So if you have a parabola in this form, an equation in that form, the vertex is at HK. The axis of symmetry is at X equals H. Remember that the axis of symmetry always goes right through the vertex. If A is positive, it opens up. If A is negative, it opens down. So this graph here, let's see, let's switch over to red. The vertex should be at -2, -3. The inverse of what's inside and the obvious of what's outside, okay? Are you following that? I'm going to take that vertex and put it in the middle of my table. And I'm going to graph it. -2, -3 is right there. From here, I'm going to go up by integer values and down by integer values. Okay, so I put the vertex at the center of my table, and then I'm going to calculate these other values. All right, this is going to take a bit, but here we go. So g of -5 is going to be 1/2 times -5 plus 2 the quantity squared minus 3, which is going to be 1/2 times -3 squared minus 3, which is going to be 1/2 times 9 minus 3, which is 9/2 minus 3, which is 9/2 minus how many halves? Let's see, we'd have to multiply by 2 over 2. So 9/2 minus 6/2, which is 3/2. So all that calculation just to get that point. -5, 3/2, which would be right about there. Okay? All right. Since it takes a lot of room to write this, I'm going to go back and I'm going to erase my calculations here. But again, you can always come back and look at the video again if you get lost there. Okay, come on, don't do this to me. There we go. G of -4 is 1/2 times -4 plus 2 the quantity squared minus 3, which is 1/2 times -2 squared minus 3, which is 1/2 times 4 minus 3, which is 2 minus 3 or -1. Okay. G of -3 is 1/2 times -3 plus 2 squared minus 3, which is 1/2 times -1 squared minus 3, which is 1/2 times 1 minus 3. Oops. Squared. Which is what? 1/2 minus 3, which is 1/2 minus 6/2, which is -5/2. Okay, now if I continue with the calculations, I'm going to get this, but I'm not going to drag you through all of that. So what does that graph look like? Let's see, -5, 3/2, -4, -1, -3, -5/2, there. Let's see here. Somehow I've messed up. Hang on. Oh, 0, -1, and then 1, 3/2. Here we go. So my graph looks like that. Okay. Notice it opens upwards. It opens wider than this one because A is between 0 and 1. It's shifted 2 units to the left and down 3 units. So the vertex is over to the left and down. Okay. Any questions about that? All right. Let's take a look at this one. So where would the vertex be? The vertex would be at 3, 2. Inverse of the inside, obvious of the outside. Okay, so I'm going to go 4, 5, 6, 2, 1, 0. Okay. And let's see, 3, 2 is right there. If x is 0, h of 0 equals -0 minus 3 squared plus 2, which is -3 squared plus 2, which is -9 plus 2, which is -7. 0, -7. If x is 1, h of 1 is -1 minus 3 squared plus 2, -2 squared plus 2, -4 plus 2, which is -2. 1, -2. If x is 2, h of 2 is -2 minus 3 squared plus 2, -1 squared plus 2, -1 plus 2, which is 1. And if I continued on, I'd get those calculations. Let's see, when x is 2, y is 1, 4, 1, and here. Notice again that axis of symmetry is at x equals 3, the same X value as the vertex. Okay. This thing opens downwards like that. Okay. So let's summarize what we can conclude here. And I've kind of already said all this. If we have an equation in the form y equals a times the quantity x minus h plus k, if a is greater than 0, the parabola opens upwards. If a is less than 0, the parabola opens downwards. When it opens up, the bottom point is the vertex. The axis of symmetry goes right through it. When it opens down, the high point is the vertex. The axis of symmetry goes through it. The axis of symmetry is at x equals h. The vertex is at h. Okay. All right. So if you're going to graph it, let's say you're going to do it by hand on some graph paper, you'd put your vertex in the middle and then find other points and plot them. All right. Now, that's doing it by hand. Doing it using Webassign, what they have us do is we find the vertex and just one other point, and then if we plot the vertex first and then that second point, it forms the parabola. We don't have to find more than just those 2 points. All right, what I want to do right now, I'm going to pause the recording. All right, now, I talked about how in Webassign things were a little bit different. So let's take a look. Let's take a look at problem number 12 over on the left side there from Webassign. Okay. Oh, I got to do a couple of things here I forgot to do. I got to do that and that. There we go. All right. So it says find the vertex and axis of symmetry of the graph of the function. We have f of x equals x minus 1, the quantity squared, plus 5. Okay. So a in this case is an implied 1. Since a is 1, a is greater than 0, the parabola opens upwards. All right with that? Okay. So we'll say a equals 1, a is greater than 0, so parabola opens upwards. All right, the axis of symmetry is at x equals h, so that would be x equals 1. You okay with that? All right, now again, if you just put 1 in here, it's going to be wrong. You've got to put x equals 1. That is the most missed problem on this test because students, especially that don't bother to watch the videos, they always mess that part up. Now, the vertex is at hk, so that's going to be at 1, 5. Okay. So 1, comma, space, 5. And submit the answer. And there it is. Any questions about that example? All right.
You had said something the other day about the placement of commas affecting whether the answer would be graded as correct or not.
Oh, okay. And that I think mostly had to do with radicals. Let's say, so this is like a whole different thing, but let's go there. Let's say that you get x equals 3 plus or minus the square root of 5. Okay, so then you go x equals 3 plus the square root of 5, comma 3 minus the square root of 5. What students will do sometimes is they'll put the comma inside the radical, and then Webassign can't recognize that. So what you've got to do is make sure that you use your right arrow on your keyboard and move the comma outside of the radical. Okay, is that what you were talking about, I think?
Yeah, I gotcha. I was curious because I played around with it and I did a space and then comma, and then I did commas right after the first part.
Yeah.
And it accepted all of that. So I was like,
Yeah.
oh, maybe they changed it. But I see what you mean now.
Yeah, it's got to be outside of the radical.
Gotcha.
Okay. Yeah. So back to this. Any questions on that example? All right, let's take a look at number 13. So here, A is -2, so this thing's going to open downwards. Okay. The axis of symmetry is at x equals h, which is going to be -3, inverse of what's inside. So x equals -3. And the vertex is going to be at -3, comma, -4, hk. So 3, -4. You all right with that? Okay, now let's go down here and look at graphing and how we have to do that in Webassign. Okay. So we've got f of x equals x minus 3 squared plus 5. The axis of symmetry is at x equals 3. The vertex is at 3, 5. Okay. So we've got x equals 3 and 3, comma 5. All right. Now, to graph the parabola in Webassign, we go to the graph and we click on the parabola that opens upwards, and you click on it. You don't want this one. You want this one. Click on it until it turns blue. Okay. You don't click on the points, just the parabola. Then I'm going to come over here to the graph and I'm going to click on the location of the vertex, which is at 3, 5. Okay. Now, after I graph the vertex, I need one more point on the graph. So how about if I just pick 4, comma something? So f of 4 is 4 minus 3 quantity squared plus 5, 1 squared plus 5, 1 plus 5, 6. So 3, 5, 4, 6. So now I graph 4, 6, and it's right there, and my parabola forms. Now, careful, sometimes the scale changes. If you have to graph some tricky points, you can come over here. And remember how way back at the very first stuff we covered in the quarter, you can come in here and manipulate the ordered pairs to make them whatever. Don't use mixed numbers, use fractions or decimals that are exact, okay? Now, what I want to do is I want to show you why you have to do it in this order. Let's say that instead I ignore Mr. Mayo's instructions and I plot 4, 6 first. That is a point on the graph, but it's not the vertex. Webassign says, oh, that's the vertex because it's the first point you plotted, and then this one. Oh, look at that. The parabola opens downward. It's the wrong parabola. You've got to do it in the correct order. Always the vertex first, then the other point. And there we have it. Okay, let's look at another one of those. How about this one? Let's see. So we've got f of x equals negative the quantity x minus 4 squared. So a is -1. So this thing opens downwards. They don't ask us that, but that'll just kind of help me if I know that ahead of time and I get one opening upwards, like I've messed up somewhere. Let's see, the axis of symmetry, x equals 4, vertex 4 comma, what's k? It's 0 because there's nothing out here. So it's like a plus 0, what is like plus 0 kind of thing. Okay. So the axis of symmetry is at x equals 4. The vertex is at 4 comma 0. And vertex is at 4, 0. Oh, I need another ordered pair. So let's see here. I've got 4, 0. How about 5 something? So f of 5, or I could pick 3. I could pick any number I want. I'm just picking something close to it. Would be negative, and the quantity 5 minus 4 squared, which is negative 1 squared, which is negative 1. So back over here, 5, negative 1. And I'm going to double check 4, 0, 5. Now, especially when you're taking a test, when you only get one shot, I would definitely come over here and make sure that your points are where you want them to be. Okay. And so we're good with that. All right. Any questions there? All right. So again, when you have an equation or a function in the form y equals a times x minus h squared plus k, if a is greater than 0, the parabola opens upwards. A less than 0, the parabola opens downwards. Low point or high point is the vertex. Axis of symmetry goes right through the vertex. They don't have us graph the axis of symmetry in Webassign. If we were doing this in a classroom on paper, you would make a graph and you'd have that axis of symmetry as a dotted line going through the vertex. But again, Webassign doesn't deal with that. The axis of symmetry is at x equals h, and the vertex is at hk. Now, we're going to wrap it up here for today in just a minute. So your homework is to get started on section 10.4. I'll be back this afternoon at 1:15 with an office hour. No class tomorrow, Veterans Day, no Zoom meetings, nothing, okay? Friday, I'll be back again at 11:30, and I'm going to take a look at the second half of section 10.4. And just what's going to happen is we're going to look at equations that are in this form, and we'll use different formulas to arrive at the same information, okay? If you just can't wait and you want to get started on it, as I mentioned earlier, you could go to YouTube to the Math 93 fall 2021 and look at section 10.4 part 2. That's basically what I'm going to be doing in here on Friday if you want to get ahead on it. Anyway, I'm going to go ahead and stop the recording.